Static NAT. In this video, I'm going to talk about static NAT. Static NAT is the simplest form of the NAT. NAT is abbreviation of the network address translation. Okay, in this video I'm going to talk about the type of static, okay, because we have differences between the different type of NAT. Now I'm going to talk about the static NAT. You know that we have private IP addresses or RFC 1918 IP address that include 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16. We could use the static NAT to convert private IP address to public IP address to communicate with the outside. Look at here. Assume that in this scenario, we have a router or firewall can be a NAT device. This device can do NAT for us, okay? And we have private IP addresses inside of our network. Here is inside of our network, okay, inside of our company. And then also we have public network in outside of our company, inside, okay, and then outside here. Now, how a static NAT can help us to communicate with the private IP address to the public IP address. You know that private IP address doesn't rotate in the public network, in the internet, for example. Okay, assume that here we have R1 with the 192.168.10 inside of company, and also with public IP address. R2 is the router of the ISP or internet, doesn't have any route to the 192.168.10. Assume that in this scenario, PC1, it wants to send traffic to the, for example, one of the IP addresses in the internet, 200.10, okay? If PC1 sends this traffic, it should use its IP address in the source IP of the packet. 192.168.110 is the source IP, and 200.10 is the destination IP. Now, these packets can reach to the R1 because R1 is the default gateway. R1 should check its routing table, and for example with the default route should forward this packet without change to the for example R2 if you don't enable the NAT. And now R2 received this packet, and R2 should give this packet to the for example server, because server is connected to the R2 or R2 has route to the server. Assume that this traffic, okay, forwarded to the server. Now server receives this packet, and after that the server should answer to this packet. Assume that server responses back with the packet with the reverse source IP and destination IP. Look at here, this is our server, okay? Server should send the response. Assume that, for example, we are using this packet in the server. The destination IP is 192.168.110, and the source IP is the IP of server 200.10. You know that server should send this traffic to the router 2, but router 2 doesn't have any route for the 192.168.110. Why? Because it's in the range of the private IP addresses. Private IP addresses should not route in the internet. We can solve this problem with the static NAT. How? It's so easy. Let me to show you how we can use the static NAT. In static NAT, we are configuring in the NAT device, okay, a map or multi-map. Map is a relation between private IP to the public IP. We should buy some public IP addresses from the provider, and after that we can use that public IP address. Assume that in this scenario we bought some range of public IP address from our provider because we have two VPC, two private IP address, VPC1 and VPC2, okay? We bought two public IP address, for example 100.10 and also 10011. These two IP addresses are both from the provider, and we have these two IP addresses. Now we can configure map in the R1. The first map is between 192.168.110 and also 10010, the public IP address we bought. And also the second mapping is between 192.116.111 with the 10011. Okay, we bought two IP address, two public IP address. We paid for them, and also now we can use these two public IP address for forwarding packets with NAT. How? Let me to review the packet that should be sent from the PC1 to the server. Look at here again. PC1 again should send its packets to the 20010. The packet reaches to R2. Now, because R2 has this mapping table, we call it translation table, or NAT table. For maybe you hear the NAT table. R1 should change the source IP. Assume that R1 receives this packet, and then R1 should change the source IP, should translate the source IP to the 10010. Now this IP should be translated to 10010. Then the packet can be forwarded to the R2. Only source IP is translated. R2 receives this packet and should forward this packet to the destination, to the server, and server should respond to the 10010. Again, because R2 has routes for this public network, R2 can forward this packet to the, for example, R1. Now R1 receives this packet. Look at here. First, the packet received by the router 2. Then router 2 sends the packets to R1. R1 now should translate the destination because the packet is received, and the R1 now can translate the destination IP to the 192.168.110. When the packet is forwarding, R1 should translate the source IP, and when the packet is receiving, should translate the destination IP. Okay, assume that we have inside and outside. When the packet, okay, is forwarded in this type of NAT, for example, static NAT. Okay, when the packet forwarded from the inside to the outside, okay, the packet's source IP should be translated. Source private should be translated to source public, or for example the source IP, public IP address. And when the packet receives in the outside interface and should forward to the inside in the reverse direction, okay, the packet's destination IP should be translated from the public destination, okay, from the public destination to the private destination. Okay, destination public, okay, to the destination private. For example, in our example, when the traffic sends from the inside to the outside, okay, the source IP is 192.168.110 and destination IP is 20010. R1 changed the source IP to the, for example, 10010, and then destination is 20010. Okay, but when the packet receives on the outside interface, the destination IP is 10010 and the source IP is 20010. Now R1 should translate the destination to the private IP address 192.168.110, and the source doesn't change. This is the static NAT. You should configure the translation table in the R1, and R1 can use this translation to find which source IP should be translated, which private IP should translate it to which source public IP in the